Hi students, today we are going to see reverse osmosis process. I am Dr. S. Rekha, Associate Professor, RMD Engineering College, Chennai. So, yes, what is desalination? As the term indicates, removal of saline, that is salt from the water is called desalination. And from where we have to remove the salt? It is from seawater. Removal of salt from seawater and converting it into fresh water is called desalination. So here the diagram which indicates the desalination process here. See here the water is taken from the sea and it is processed with the help of an energy, okay, and the salt and minerals are removed and given back to the sea and you get the fresh water here. So saline water, sea water can be brought back to us fresh water. So that is desalination process that could be done by RO membrane. So the same thing could be represented in the other form. So we take sea water in the desalination plant with the help of certain amount of energy. It is processed and fresh water is removed. Waste brine is let into the sea itself. Okay. Water containing high concentration of dissolved salt or solid with peculiar salty taste is known as brackish water. Okay, peculiar brackish water. Treatment of brackish water mainly includes desalination process. The salinity of water is expressed in ppm or milligram per liter. So amount of salt present in seawater is measured in ppm, parts per million, or in milligram. The quality of water is graded on the basis of the salt content. So fresh water, if it is less than 1000 ppm of dissolved total salt, it is dissolved total salt means it can be calcium, it can be magnesium, it can be sodium, it can be potassium, it can be anything. So total salt content should be less than 1000 ppm, then it is called as fresh water. If in brackish water, then it is more than 1000 and to 35,000 ppm of dissolved salt. Seawater is generally 35,000 to 50,000 ppm dissolved salt, and briny water which is more than 50,000 is highly salty in nature. So based on the salt, water can be graded into 4 types. Two techniques are used to remove dissolved salt. One is separation of brackish water by electrodialysis method. Another one, separation of brackish water by reverse osmosis method. Today we are going to talk about reverse osmosis. So reverse osmosis is otherwise called as membrane filtration, otherwise called as superfiltration, even it is called as hyperfiltration method or process. Reverse osmosis is a method which is capable of producing soft, pure, drinkable water in a large scale. It can be used for domestic as well as for industrial use. But previous method, if we consider, it is distillation and freezing process, which takes more time, more energy, which is expensive, and the amount of output is also very small. Okay. In Arabian Gulf countries, the quality of water is very poor, so that the government itself is dependent on RO process for solving out the problem of water supply for municipal as well as for industrial use. But in our municipal water, we don't go for RO membrane treatment. It is just removal of the sediments and germs. First we'll learn about osmosis, then we will see about reverse osmosis. Osmo means push, sys means process. A process with a push is called osmosis, and let me tell you, it is a natural and spontaneous process. For this process we need not supply any energy at all. It is natural and it is spontaneous in nature. What is osmosis? When two different solutions are of different concentrations are separated by a semi-permeable membrane. What is a semi-permeable membrane? a membrane which allows only the solvent molecule to pass through it, stopping all the ionic molecules, stopping all the dirt particles, stopping all the organic molecules, everything. It allows only the solvent molecule to pass through it. It is called as semi-permeable membrane. Okay, when a liquid of two different concentration is separated by a semi-permeable membrane. Okay, so what happens? Water molecule from lower concentration move towards the higher concentration. Why this happens? I told it is a spontaneous process. Why this happens? This happens due to concentration gradient. In nature, tries to balance out everything. So here we have two different concentration separated by a semi-permeable membrane. Nature finds its way to shift the water molecule from lower concentration to higher concentration until the concentration on both the sides is same. So this process happens because of concentration gradient, and the force with which this water molecule from lower concentration side move towards the higher concentration side is called as osmotic pressure, and the movement of water from lower concentration side to higher concentration side is called as osmosis. The pressure exerted on the membrane is called the osmotic pressure. So let us consider the example as given in the picture on the left side of the slide. See, we have a semi-permeable membrane. Two sugar solution is separated. One is at lower concentration, another is at higher concentration. After 5 minutes, if we observe, the diagram would be of the other type. Because of osmosis, water molecule have traveled from this end to the other end until when the two concentration is equal. Until this process will continue until the concentration on both the sides is equal. Okay, so this is called osmosis, and this we have found in late centuries only. This is happening in our body. In the right side you have a picture. This is a cell in our body. So cell membrane is covered by a semi-permeable membrane, and this semi-permeable membrane always absorbs water from the outside to the cell for the purpose of functioning of the cell. It absorbs the water just by reverse osmosis process. Now we'll see what is reverse osmosis. See, when water from lower concentration moves towards a higher concentration and it becomes neutral, that is, the concentration becomes same, it does not serve any purpose to us. This is naturally happening, a balancing out, but we want something where we want from impure water, we want a fresh water that is having zero concentration of salt. So what we can do? So if we are able to apply a pressure on the opposite side, that is on the higher concentration side, we can reverse the osmosis process to the other side. That is, water flowing from lower concentration to higher concentration. We want to just reverse that water flowing from higher concentration to lower concentration. This could be achieved by applying a pressure greater than the osmotic pressure on the higher concentration side, so that we will be able to push the water from higher concentration side to the lower concentration side through the semi-permeable membrane. So this is called reverse osmosis. You can see the diagram here on the left side. So this is osmotic flow. Okay, from lower, light blue is lower concentration, dark blue is higher concentration. So water flows from lower concentration to higher concentration. Here we have reverse osmosis. See, on the concentration side, I apply a pressure which should be greater than the osmotic pressure. So when we apply a pressure greater than the osmotic pressure, what happens? Water from higher concentration side moves towards the pure water side, that is blue side, where we don't have any salt content. So the process is reversed and we are benefited by getting a fresh water. We have another diagram to be explained here for your purpose. So here we have in the YouTube, we have the semi-permeable membrane. Okay, the first one is osmosis, and here again a pressure is exerted on the concentrated side and the process is reversed and we get a pure water alone. No other chemical is there, no other ion, salt, anything is available on the other side of the water. So process, how a reverse osmosis process works. So here we have a diagram, okay, where we have a semi-permeable membrane, the brown one in the middle, okay, and the topmost part you can see all the impurities. We have molecules, we have ions, we have dirt particles, everything, okay, and bottommost we have the pure water or lower concentration. So when we apply a pressure on the upper side, what happens? Only the water molecule is moving towards the other side and we get 99% purity of water here. Okay, we get a purity of 99% of water and everything else is rejected. Ion is rejected, ions are rejected, that is cation is rejected, anion is rejected, molecule, organic molecule is rejected, any dirt particle which is present is rejected, everything is rejected. Only the water from one side to another side it is forming with a, and the method is also very cheap. So this is the diagram which you have to draw in the university examinations to explain the reverse osmosis. See here middle part we have the semi-permeable membrane. So this side we have the impurity and here we apply the pressure. From the pressure we have the treated water. So this diagram we have to draw for your university examination so that you can explain reverse osmosis. So this is a block diagram of process of reverse osmosis. So where this reverse osmosis unit is applied? It is used in nuclear power plant, it is used in high pressure boilers, it is used in beverage industries, it is also used in homes for drinking water purpose. What are the advantages of your RO? Converting seawater into drinking water. A large amount of water. We are surrounded by water but we don't have a proper drinking water. So from there the solution came. Seawater can be converted into soft water. So the reverse osmosis process is helping it to convert it into drinking water. So it removes all types of impurities, ionic, non-ionic, colloidal, everything. Lifetime of the membrane is high. It is 2 to 3 years. Low energy consumption. Cost of purification of water is less and maintenance cost is also less. This water is mostly used for high pressure boilers. High pressure boilers we need to handle it very safely and where we should ensure that there is no impurity in water at all so that we can avoid boiler explosion. So this is used there. Disadvantages. Again, most important costliest part is the membrane, but as it comes for 2 to 3 years, it is affordable. Membrane should withstand a very high pressure. The strength of the membrane should be to withstand the pressure more than the osmotic pressure which we are applying. The membrane must be capable of withstanding pressure of the order of 20 to 100 atmosphere. So that is the requirement. So accordingly we have to design the membrane for it. We cannot say it is a disadvantage. Only one thing, it is a little costlier method, but where it is required, where the safety is important, we need not go with the cost effective. And here we get a highly pure water. This is the diagram of the RO unit which you have at home. Okay, so here we have so much of tubular arrangements so that water is filtered and removed. So here I will play a video for you for the looking into the arrangements of how it is arranged and how it functions so that we will have a really practical knowledge about how a RO membrane works out. Okay, every family is having one unit of RO and we are drinking only this RO water in Chennai now. And we are not aware how it is functioning. It's a simple thing. Dear students, today we are going to see the RO unit which is available at everybody's house, especially in the kitchen, for the purification of water. So we are going to see the inner part of the RO unit, how it functions and how fresh water is formed. So we will see the inner part of it. This is the inner view of the RO unit where we have 4 chambers of filtration. Okay, this is my own unit. I have dismantled it only to show you for better learning. So here we have first chamber called as pre-carbon filter. This pre-carbon filter filters the dust particle, organic matters, everything, and this wire is the inlet wire from which the water enters into the pre-carbon filter, where it is all the coloring agent, everything is filtered. And second one is the sediment filter. As you can see here, all the sediment particles, fine particles are again filtered off, and from here the water goes into the RO membrane, which we have learnt, RO membrane, where the ionic and non-ionic particle are filtered. 100%, 99% purification take place, and then from that it gets into the post-carbon filter, which is a fine carbon filter to ensure the purity of the water. Filtering any dust particle from the filter should not enter into it, so it is being filtered. So our RO unit may have a maximum of 7 stages. It depends upon the water which we require. Stage 1 is the sedimentation. Here it is a cotton roll, okay, which is kept outside the unit for pre-filtration of water to remove the dust particle, everything, okay. And next, second stage 2 is GAC, that is granular activated carbon, which is used to purify the water. And to that next stage it is CTO. This CTO is not present in every unit. It is present in certain special unit. And this is what is CTO is chlorine, taste and odor. Every RO water has its own taste. The taste is provided by this unit. And this is C stands for chlorine, T stands for taste and O stands for odor. Okay. And next is the most important one is our own RO membrane, and this is through which the water moves and where the complete purification process takes place, and then the water which is coming out of it is get into a post-carbon filter. So the first one is stage 2, which we see is called as pre-carbon filter, and stage 5 it is called post-carbon filter. Any fine particle, still it is there, it will be filtered off here. And next one, stage 6, again it is not available in every unit, certain unit only it has. It's a very important part. Why? The RO water which is coming out of the unit is free from, as we learn, it is free from ions, non-ions, molecule, everything. It means it is free from minerals also. Basic minerals for our body we get from only water, and the water RO which we are drinking does not contain any mineral. So to artificially add certain percentage of mineral, this unit is prepared. So through which if the water moves in, it balances out the pH level, alkaline level of water, and also adds few amount of minerals to it. Okay, that is stage 6. And stage 7 is also not available in every unit. Any water where you want to kill the germs. Okay, then we have this UV lamp. The UV lamp glows and kills the germs in the water and purifies it. And so here stage 3, stage 6, stage 7 is an optional one in any filter. It depends upon the need of the person or the place of water where we have to use, and accordingly we fit in. So when we say reverse osmosis, it is not only the membrane, it's see how many filters we have used. Everything plays roles in it. Yeah. Our RO membrane unit, how it look like, it has so many layers. Okay, it is just a unit which we have seen. Okay, it has so many layers. See, we have a lowermost, we have the pink color one is semi-permeable membrane. We have beneath, we have a green color sheet which is a permeate carrier material. We have above string-like material, that is feed water carrier. To there need to be a gap for the water to travel. Everything is rolled out completely to form a single unit, and in between we have a blue color tube which is a perforated tube for the traveling of water. Okay, from that water it travels and it passes through the membrane and it is filtered, and water is removed at one part and the concentrate is removed at the other end. So this is the cross-sectional view of the our RO membrane unit. Yeah. Now difference between reverse osmosis and demineralization process, which we have learned already. What is the major differences about it? So as I said, any differences, first it should go with its definition. So water passes through the semi-permeable membrane against its concentration gradient and facilitated by high pressure. So by applying high pressure, we get the pure water passing through semi-permeable membrane. In demineralization process, it is the ions between liquid phase and ion exchange resin. It is the exchange of just the ions. RO process is a physical process. Demineralization process, we can say partially a physical as well as a chemical process, physiochemical process, because there is an exchange of ions taking place there. It removes both ions and non-ions in reverse osmosis. It removes only the ionic impurities, cation as well as anion. Membranes is used to filter. The main unit is membrane, which is used for filtering. Here the main unit is resin, which exchanges the ions. In RO, again it is removing the particulate and suspended particle, but where demineralization does not remove the particle and suspended solid. Higher amount of wastewater is produced, less amount of wastewater is produced. That's the part of it. Here the higher percentage of wastewater is produced. Here the less amount of wastewater is produced. This is the actual RO unit in the industrial scale. So how this tubular look like? So whatever we have household unit was a so small thing. So here we have an industrial view, how they are arranged, how it moves from one membrane to a large scale unit preparation. Okay, really feeling like engineering, right? Feel proud to be an engineer. See how uh, design, how complicated design it is. Process was so simple RO, but see how when it applies to industry, how complicated design it turns out into be when you are going for a large production of the. Thank you, children.